All right, time to shift gears. Much as I love 486s, hey, even I need a break from them sometimes. Quick shout out to my Patreon supporters who voted on a poll to determine what my next video was going to be. There were some very interesting choices on that list, but the clear winner by a long shot was another 3dfx repair and enhancement video. If you'd like to learn about how to support the channel and become a Patreon member, you can find some links in the description below. Anyway, enough of that. In front of me here is what I like to call a bit of an impulse buy. Did I really need more Voodoo 3 cards? No, not really, but when I saw these two neglected, untested cards with no brackets for $45 each, well, they sort of just followed me home. The Voodoo 3 1000 is a bit of an odd duck. As far as I know, it was never sold in the retail channels and was used exclusively by OEMs like Gateway and Compaq in the 99-2000 timeframe. It's basically a low-cost, underclocked Voodoo 3 using the same fully functional Avenger chip. They also simplified the PCB layout a bit and ditched all of the TV out circuitry. These two cards here are nice and shiny and clean looking, but yeah, that was not the case when they first arrived. They were absolutely filthy with a thick layer of grime on them. Cleaning with isopropyl alcohol just sort of smeared the dirt around, so I had to take some more drastic measures. Gave them a full soap and water cleaning in the sink. I know there's probably some people watching who might be a bit shocked by this, but as long as you take the necessary precautions, it's actually quite safe. Just a few quick tips if you ever do try this. Number one, be sure to give the card a very thorough rinse with distilled water afterward while it's still wet. You don't want any mineral deposits left on the card, which can cause problems. And number two, obviously, they'll need to be completely dry before you try to use them again. I'd say give at least 24 to 48 hours if you want to be on the safe side. But I left them on top of an electric radiator at the minimum heat setting so they were nice and warm to the touch, and that really sped up the drying process. Would be nice to get an ultrasonic cleaner one day for doing this sort of thing, but I don't think I do it often enough to justify the cost. But yeah, they look super clean now, that's for sure. These two cards here are pretty much identical. They are Compaq OEM parts with 16 megabytes of memory. And as you can see, they have no heatsink whatsoever. They were not removed, they just really don't have one, which is kind of shocking if you know just how hot Voodoo 3s run. But I will get more into thermals later. Now, to make things as confusing as possible for people, there's actually several variations of the 1000 from different OEMs out there, including both 8 and 16 megabyte versions, as well as some with and without heatsinks. The standard clock speed for the 1000 is 125 megahertz, but yeah, for some strange reason, there are 143 megahertz cards out there too. Here's a photo of a Voodoo 3 1000 taken by one of my Patreon supporters, Michael Barry. This version is a Gateway OEM card. It's 8 megabytes, 143 megahertz, and includes a heatsink on it. It actually looks like it shares the same PCB as the Velocity 100. Looks almost identical, really. So just if you're in the market for one of these, keep in mind that they are not all created equal, and sometimes you do have to look pretty closely to know exactly what you're getting. Despite the many variations, the 1000s all seem to have one thing in common. They use SGRAM memory instead of the SDRAM that's found on the higher-end retail cards. Only some of the PCI versions of the Voodoo 3 2000 and 3000 seem to use SGRAM as far as I know. But unlike SDRAM, SGRAM is tailored specifically for video card use and has slightly higher memory bandwidth at the same clock speeds thanks to a number of efficiency improvements that I won't go into today. But one thing I've noticed on 1000s is that the SGRAM memory used is often rated for frequencies much higher than 125 megahertz. For example, both of my cards here are using 6 nanosecond SGRAM from Siemens, which should be good for up to 166 megahertz. That's Voodoo 3 3000 performance levels. I even have another card in my collection here that has 5.5 nanosecond SGRAM, which is good for up to 183 megahertz. I don't really think they did this for any specific reason other than it was probably just what was readily available for use at the time. But it's a nice bonus any way you look at it because the more costly retail models will almost always use the SDRAM matched for their core speed. So it's usually the limiting factor when it comes to overclocking. And yeah, I think you can probably already see where I'm going with this. But don't want to get too far ahead of myself. I do need to thoroughly inspect these two cards, then test them out to see if they even work. And since I'm going to be working on both of these cards today, I think they're going to need some very creative names. So I'm going to call this one card number 1, and we'll call this one card B. No, I won't do that to you. I'll call them card 1 and card 2. All right, so I'm out in the garage where my soldering gear and microscope is. Let's inspect these things and see if they need any repairs. Now, the most obvious thing missing on these are the slot brackets, a telltale sign that these were in the hands of scrappers at some point. And in some ways, I'm actually glad this particular 1000 model has no heatsink, because at least they didn't try to pry it off with a screwdriver, destroying the Avenger chip and the BGA joints in the process, something you see all too often, unfortunately. Now, I'm not quite sure what I'm going to do with the brackets yet, but for now, I'd say that's sort of the least of my worries, really. Card number 1 was the dirtiest of the two when it arrived, but the only obvious sign of damage I could see is the electrolytic capacitor at the back edge of the card over here. So it looks like it broke clean off, and this combined with the dirt sort of tells me that the card just wasn't stored properly. Really no surprise there. There is one other electrolytic cap here by the voltage regulator that looks pretty banged up. It's dented on the top, and I don't like the look of it at all. But I'll probably just replace the missing one for now. I do want to make sure that this card is at least somewhat functional before investing too much time into it. But let's get this one under the microscope, see if there's any other damage I need to worry about. As I mentioned, the electrolytic caps were a bit banged up on this card, but I could also see a bit of a sticky substance around the base of at least a couple of them, including C79 and C111. Not 100% sure, but it could be the magic fish juice leaking from the caps. And yeah, it really does smell a bit like fish. Here's C88 that was broken off. There's a bit of corrosion here too, even after washing the card. Also, I noticed there's a bit of a film on the PCB in some areas. I thought maybe it was from the soap and water from earlier, but I can actually see my brush marks through it. And the card 2 doesn't have this at all, and I washed it the exact same way, so I wonder if this one was exposed to water at some point. I thought the cap broke clean off, but not exactly. The legs actually snapped right off and are embedded in the solder. Must have been a fair bit of force to do that, I think, but thankfully the pads weren't damaged. I'm going to add some flux here and get these pads cleaned up. First, I'm going to just get them reflowed so I can wipe away those broken pins. Then I'm going to use some copper wick to get all of the old solder off there. And of course, going to give the area a good cleaning with isopropyl alcohol and the forbidden toothbrush. All right, looks nice and clean now. Time to get a replacement cap added. I'm just going to add some flux and then tin one of the pads. Then I'm going to hold the new one in place with some tweezers while I reflow that pad. And you can kind of just see that pin sink in, which is great. Unfortunately, I didn't get it on very straight, and it's outside the silkscreen footprint, so the perfectionist in me just had to redo it. Yeah, I know. For anyone wondering, these are Panasonic FK series caps, 10 microfarads and 16 volts with a 4mm footprint. Very common spec that's used on many 3dfx cards. We'll put some more detail in the description below for anyone who's looking for these. There we go, looking better. Just added a bit more solder on the first side again, and it's time for some cleanup with some isopropyl alcohol. And the end result looks pretty clean, I think. I was almost ready to call card 1 good to go, and almost missed it, but there's a larger 1206 SMD cap that's near the AGP slot clip labeled C85. Just looked a little bit off to me, and sure enough, with a slight poke, it moves around freely, so we've got a broken cap and or solder joint here. Although it may be tempting to just tack it back into place with some fresh solder, the component is clearly broken, and yeah, I don't think it can be trusted anymore. As you can see, I was able to pull it off with almost no effort at all. That's a pretty big chunk missing from the one side, but I am curious to see if I can get any kind of reading from it. Matches a common capacitance value. But yeah, it's measuring 1.62 microfarads, which is a bit of an odd value, so I'd say this cap is toast. Unfortunately, I haven't been able to find a component map anywhere for the Voodoo 3 1000. Component maps are sort of like blueprints that give the ratings and specs for every component that's installed on the card. Here's an example of one for a Creative Labs Voodoo 2 that I've used in the past. But yeah, without this, I really have no idea what this cap's true value should be. Unlike resistors, capacitors can't be reliably checked with a multimeter while they're installed. And that's because the multimeter will get the capacitance for the entire circuit, not just the component the probes are touching. The only way to get an accurate reading is to remove the cap completely. C85 looks just fine on card number 2, so it's going to be going under the knife to help out its friend card number 1. But before we do that, I'm just going to get these pads cleaned up on card number 1. As you can see, there are some pretty big chunks of capacitor coming off here. Alright, so let's get C85 off of card 2 to get a measurement. I don't want to use hot air for this, as it's quite a bit overkill just to remove one component. Plus you got all the mess and the fumes. So I'm just going to use my iron instead. I'm going to remove my favorite conical tip here and replace it with a large knife tip. This one's wide enough that it should be able to heat up both sides of the cap simultaneously for easy removal. Okay, so I'm just putting a generous amount of flux on here. And the wide knife tip makes really quick work of this. Came off super clean, actually. And while I'm here, I'm just going to get those pads cleaned up too. All right, let's see what C85's true value is. Aha, 3.3 microfarads, so that's a more common value that makes a lot more sense. The old one was way off. It was like half that capacitance. So I'm going to need to add one of these to my shopping list. Rather than put this back onto card 2, I'm just going to go ahead and install it on card 1 so that I can get it finished and tested. Some fresh flux going on here, and yeah, I gotta say I like working with 1206 components. The larger size just makes everything easier. One side done, and the other. Wasn't totally centered, but hey, looks good enough to me. Okay, card 1 is whole once again. We got the missing electrolytic capacitor replaced, and the badly damaged C85 has been replaced with card 2's. Now, assuming this card works, I still will deal with the other sketchy caps, so don't worry about that. This here is my Voodoo 345 test bench. It's an Athlon Thunderbird at 1.3 gigahertz. A little bit newer than a Voodoo 3, but good for testing because there won't be any CPU bottlenecks holding the card back. The motherboard is an MSI K7T266 Pro based on a VIA chipset. It's already got all of the drivers loaded, and I tested it earlier with my working Voodoo 3 1000, so there should be no software shenanigans to worry about at all. Okay, moment of truth. Oh, might help if I turn the power on. Oh, we have display. One interesting thing to note is it didn't display the iconic Voodoo 3 post message when the system started, just had a blinking cursor. My other 1000 does the same thing, so I assume this is normal, just something they did for OEMs, I guess. But yeah, this is looking good. The 3dfx tray icon showed up right away, so that tells me the driver's loaded, and I can confirm it's a 16 megabyte card clocked at 125 megahertz. But getting to the Windows desktop is one thing. Will it be 3D stable? Let's launch good old Quake and see. Nice, looking good. Not seeing any artifacts either. I'm not going to spend too much time running demos right now, but it's definitely good enough for what I have planned. More on that in a bit. Alright, so with card 1 mostly fixed, let's move on to card number 2, which was the less dirty of the two when it first arrived. And yeah, you can see some of the feature connector pins are bent out of shape, and there is some deep scratching just below it that I'm going to need to take a closer look at. But it's missing the same electrolytic capacitor, C88, on the edge here. But looking more closely, I also spotted an 0603 SMD ceramic cap that was broken off down near the AGP connector, which is labeled C76. So yeah, that's going to need to be replaced. Another thing I'm a bit concerned about is the slight bend in the PCB. It's not terrible, but it is enough that I'm a bit worried about the BGA joints. Hopefully they're okay, but I won't really know until I have a chance to test it. But anyway, let's get this thing under the microscope and have a closer look for any other damage. Here are the bent feature connector pins, which I'll straighten out later, but I'm more concerned about this deep scratching here. These traces have seen better days and the copper is exposed, but none of them look severed, so that's good. I'm just going to leave this damage as is. The electrolytic caps definitely look better on card 2. No suspicious goo leaking out or major dents in them. And here's our friend C88, broken clean off this time. You can see the indentations where the pins used to be. I'm going to do the exact same thing I did with card 1 here. I'm just going to clean up the pads, and then I'm going to get a fresh Panasonic FK series cap installed. And here's C76 that broke off. There's actually a tiny sliver of cap left here, but I don't think that's going to provide any capacitance. Thankfully, the pads look okay. And yeah, as you can see, we've actually got another sketchy looking cap right next to it, C65 with a big chunk out of its corner. It is securely attached, but I really don't like the look of it, and it's got to go. So it looks like card 1 has the opportunity to return the favor after all, and I'm going to need to remove C76 and C65 from it to get some proper measurements, and then I'll order some replacements. I think the big knife tip will be too large for these 0603s, especially with them so close together. So I'm going to try this chisel tip instead. It may actually be a little bit too small, but we will see how it goes. But first, let's get these bits of cap removed from C76. And yeah, that chisel's a bit too small for an 0603. I'm going to see if I can get a smaller knife tip for jobs like this. And that didn't come off too gracefully, but it did work. Just getting these pads all cleaned up and ready for the replacements here. I do want to measure C65 since it was mostly intact. If I'm lucky, I may match a common value, and that'll be one less component that I need to remove from card 1. But let's see what it has to say. 0.7 nanofarads. No, that's an odd value. We're going to need to check both caps from card 1. Okay, so I've got card 1 under the microscope, and C76 and C65 are in great shape. I wasn't a fan of the chisel tip, so I actually went back to the knife tip here. It is way too big, as you can see. It still works, though, and just have to be a bit careful, that's all. I'm putting these in numbered holders in my silicone mat. That way I don't mix them up. Now let's get C76 off of here. Nice, that came off really cleanly. All right, so let's get some measurements starting with C65. Beautiful. Very clearly 1 nanofarad, a value that makes sense. Next, moving on to C76. Nice, 1.000 nanofarads, so no doubt there at all. They are both the same value after all. All right, so good news. I didn't place an order yet, but I came across an unopened bag from DigiKey in my parts bin. I've got exactly 2 1000 picofarad caps, which is equal to 1 nanofarad. And they are 25 volt rated, X7R, which is the higher temperature rating, and 0603, which is perfect. I don't remember what project this was for, but it looks like I bought them back in August of 2020, and we'll get to put them to good use after all. All right, so let's get these caps installed on card 2. I'm going to start with C76. First side looks good. And yeah, way too much solder on the second side. Big blob there. I'll see if I can clean that up after. Moving on to C65. First side looks good. Second side looks good too. That one's nice and clean. Just moving back to C76 to get some of that excess solder off. And that looks a lot better. I know it really doesn't matter, but I do try to keep these things as clean as possible so they don't really stand out. Nice, quite happy with that. It is now time for me to place a new DigiKey order for some parts to replace all the loaner components I stole from both cards. All right, my order has arrived. I don't know if it's just me, but I always get super excited when I get a package from DigiKey. But yeah, there's a lot more than just SMD caps in here. Some exciting bits for these cards that I won't spoil for you yet. But included is the 3.3 microfarad replacements, as well as some 1 nanofarad 0603s. And I always order lots of extras too for future use. Let's get the big 1206 3.3 nanofarad cap replaced on card 2. I just did a bit of a test fitting here to make sure I got the right size, and yeah, it looks good. Adding a good amount of flux to the pads here. And yeah, the more I get experience with soldering, the more I realize that you just really can't use too much flux, as long as you don't mind cleaning it up afterwards anyway. Getting it lined up just right on the pads can be a bit tricky. Usually when I press it down, it ends up moving, so I just try to take my time with this part. There we go, nice and clean. And last but not least, I'm just installing the 1 nanofarad caps on card 1. I didn't end up reusing the old ones as they were a bit of a mess after removing them, so I get some fresh ones instead. And there we go, looks good, and both cards have been made whole once again. Okay, so card 2 is good to go. I got the feature connector pins all straightened out, C88 has been installed, and the 2 1 nanofarad ceramic caps are replaced. And of course, the borrowed 3.3 microfarad cap at the corner has been paid back in full. So it's finally time to test this one out. Really hoping that the bent PCB won't be a problem, that the ball joints are good, but there's only one way to find out. Moment of truth, let's see what happens. Oh, we have display. Looking good. And I'm pleased to report that card 2 is 3D stable, appears to be working just fine. I was hoping to get at least one working card out of the deal, but hey, 2 is a bonus. Anyone who's owned a Voodoo 3 knows that these things run really hot, but I was not prepared for just how hot this undervolted, underclocked version could really be. After thoroughly toasting my finger, it was time to break out the thermal camera. After a few minutes at idle, it would hit about 95 degrees Celsius, and after only a few minutes at Chipquik, it was pushing 106 degrees Celsius, hot enough to boil water, and this is in an open test bench in a well-ventilated, air-conditioned room. So just how bad is 106 degrees Celsius? Well, according to 3dfx, that is already beyond the maximum that the chip is rated for, a 105 degree case temperature and a 125 degree junction or internal core temperature. How anyone thought it was a good idea to skip out on a small aluminum heatsink to save a few cents is just totally beyond me. Even the models with heatsinks just run way too hot, really. And yeah, it's no wonder so many Voodoo 3 cards have BGA contact issues. The extreme heat, and especially the heating and cooling cycles, can cause the solder balls to crack. If there's one important message to take from this video today, add some airflow to your Voodoo 3 card if you really care about it and want it to last. It really is very important. One thing I did want to check was to make sure that the core voltage wasn't way out of spec or something. There can be a little bit of variation from card to card, but it should be around 2.2 volts for the 1000. Card number 2 here is measuring 2.28, almost 2.29 volts, so a little spicier than it should be. And card number 1 is even further out of spec at a little over 2.3 volts. You'd think card 1 would actually run hotter as a result, but it actually runs a few degrees cooler, hovering around 100 to 101 degrees at load. Small overvolt like this may not sound like much, but for a card with no heatsink whatsoever, it is definitely not helping its cause. Well, I say no heatsink at all, but actually that's not totally true. The entire card itself is one big heatsink, and that's all thanks to hot balls. Wait, that doesn't sound right. Thermal balls, that's the one. So here's a really sad looking Voodoo 3 3000 that I'm going to use for illustrative purposes. This card is actually in the mail on its way to me right now. Big thanks to This Old Tech, another Patreon supporter, fellow Canadian, and all around great guy. He got this card from a friend of his 4 or 5 years ago who sadly had a sort of worst case scenario heatsink removal experience, shall we say. Another cautionary PSA, please don't remove a Voodoo 3 heatsink unless you absolutely need to. This card is way beyond repair, unfortunately, but will be put to good use for parts, mapping out traces, stealing components, and, well, inclusion in videos like this. The chip has several rows of balls around the outside providing all of the electrical connections, grounding, signaling, etc. But there's a large number in a square shape right at the center of the chip, directly below the die. And these have no electrical connection whatsoever and only serve to transfer heat away from the core and into the PCB. There's a fair bit of copper in the ground plane and throughout the card, so it really does help to lower the core temperature. And that's why you'll see this small metallic grid at the back of the card too. That's where these thermal balls make contact. It's usually perforated too, so I suspect it may be to allow some heat to escape via convection when the card's mounted in the normal position in a tower. But I have seen people mount small heat sinks back there too, and I probably avoid doing that just because you don't want to block the holes. Here's a view of the back of the card with the motherboard in a vertical position. You can see a lot of the heat is getting into the PCB here. It's over 70 degrees right around where the chip is, and around 40 degrees or so around the edges. Here's an interesting time lapse over the course of 5 minutes from the moment the system is powered on to running demo loops in Chipquik. You can quite clearly see the heat conducting outward as time goes on. It is a system that works, but even for a low power 4 or 5 watt version of the Voodoo 3 like this, it's just not enough. I ran these cards for just a few minutes like this, for science, but I am not going to leave them like this for any length of time, that's for sure. I started putting a big 120mm fan right next to it. Even without a heatsink, this is more than enough, and like this, the chip just gets slightly warm. Temporary solution for now. Obviously, you'd never want to overclock a card pushing 100 plus degrees, but now that it's at a reasonable temperature, I'm going to try to get some baseline overclocking results out of these. I'm using a program called V.Control to do this. There is a 3dfx Overclocking tab that can be enabled as well, but I really prefer this program. The clocks apply immediately, and you don't have to reboot or anything. There's also a ton of other settings here that you can play with if you want. After slowly increasing the frequency a few steps at a time, I got an end result of 158 MHz on card number 1 and 156 MHz on card number 2. They really are on the edge of stability though at these clocks, so Probably a safer setting would be around 152, 153 megahertz, somewhere thereabouts. But yeah, that's around a 25% increase and well beyond the 143 megahertz of the Voodoo 3 2000 with way less core voltage. Really good sign for what I have planned. Now when it comes to thermals, one solution would be to just undervolt the cards, assuming they can remain stable, and I expect they certainly could with the very healthy amount of headroom in the core. But no, not going to go that direction. We're going to correct this terrible wrong done by the engineers who made this card at 3dfx or STV or wherever they were made. Their cost-cutting days are over. We're going to unleash the full potential of these cards and get them behaving like proper Voodoo 3s, better than Voodoo 3s even, and that means an active cooling upgrade, more voltage, not less, and some other tweaks perhaps. But this video is already getting a bit too long, so you'll have to stay tuned for part 2 of this video series, which is going to be all about the enhancements. But that's it for today. Thanks very much for watching. If you enjoy my channel, please consider supporting me on Patreon. You'll get early access to my videos, exclusive behind-the-scenes content, and some other perks too. And as always, be sure to check out the description below for links and other useful information. Thanks again.